Hey everyone, welcome to another episode of the Kubernetes Show. And I'm your host, Hardeep Singh Tivana, with over 2 decades of experience in IT, one of the Kubesnots. This week, we have our topic for our advanced users. Some of the folks who are connected to me on LinkedIn, on other platforms, they requested for videos which are for some advanced users too. Last week we did a video on Linux. We started with getting started with Linux. This week we'll get into Docker, Kubernetes. Uh, During this week, idea is first understand why containers, how did we land into containers. We'll look at one container too. We'll run a web server. All this code, everything that you see here is uploaded on GitHub. I'll provide the links. And finally, I'll close with a script which I had to write and modify. Basically, idea is you should have a way to create your cluster to consistently spin up your environment so that tomorrow if you are troubleshooting something, you ask me a question, I can recreate something similar in my environment too. If we are on same page, makes our life easy. But anyways, with that, let's get started. So this page that you see, it is already there on the Kubernetes show GitHub repository. Inside that, if you go into Kubernetes, you'll see a readme.md file. As soon as you land in that repository, you'll see page like this. So how did we land into containers? Before we do that, we need to understand the history of virtualization. I know I don't want to make it a history class here, but to understand this better, I think we need to understand a little bit about history of computing. When did it all started? Why virtualization? All right, I'll not go into when computers were created, but let's talk about virtualization. It started somewhere in 1960s when people were, or IBM mainframe folks were trying to run multiple operating system on a single machine. When we say virtualization, that means we are making a copy of something, right? Initial idea was creating copy of the full operating system. And it all this started with not being able to utilize the operating system or the underlying hardware 100%. That was one reason. Second reason for this was there were applications that people didn't want to install on the same server which is running their production. So they wanted to have a way to kind of segregate their production code versus development code, but not by another server to do that, right? So in the end, what they wanted to do was have maybe one BP server and on top of that run 3 or 4 operating systems. Now this concept, for anybody who is starting new in computer or IT, it might be new, but whosoever has worked for a little bit, they understand what virtualization is. Imagine your phone being able to run Windows, Linux, iOS. It is that kind of setup, right? There are some software that do it on the phones too, but anyways, on your laptop, if you are running Mac OS, you want to run a Linux machine too, or you want to run a Windows machine too, while your Mac operating system is still running. So having more than one operating system running, that is kind of virtualization. What we are virtualizing? We are virtualizing kind of hardware. Basically, it is simulation or emulation of underlying hardware to make operating system feel that it is running on a physical machine, whereas it is actually running inside a virtual machine, right? So there are multiple types of virtualizations available. I've listed some here. Hardware virtualization, for example, QEMU does that. Then there are operating system virtualization. We were talking about, you can run multiple operating systems. You can have network virtualization storage. There are many layers. I have not listed everything that is possible with virtualization, but there are a few I did list. Now, before we kind of dive a bit deeper into it, there are different types of hypervisors. When we say hypervisors, or what is a hypervisor? Hypervisor is something that runs these virtual machines, a software that enables running more than one operating system on a physical box or physical laptop or physical desktop. That is what is called hypervisor. There are two types of hypervisors. One is bare metal type, another is hosted type. Now the difference is, from this picture you can see you have a hardware machine. On top of that you are running hypervisor. This is called type 1 hypervisor. This is piece of software which is kind of making multiple copies of that hardware available to run more than one operating system in their own little environment, which we call it VM. VM is virtual machine. Okay. So then there are type 2. Type 2 are, you have hardware. On top of hardware you installed operating system. So you have some full-fledged operating system. On top of that operating system there is a thin layer which is called hypervisor layer. That layer is again providing something similar to kind of segregate or make multiple copies of the operating system available inside different VMs, right? You are slicing your physical hardware to make it look like, these are 10 different servers maybe, right? In this example we are doing 3. But anyways, difference in both of them is this host OS layer. The more layers you add, the slower it becomes, because every layer need to do translation. When your software sends a command, the command goes to VM. Inside VM also there is operating system. Now that operating system sends it to hypervisor. Hypervisor sends to underlying host OS. From host OS it goes to hardware, and then finally it gets executed. You can imagine how many layers are coming into it, and it slows it down. So type 1 are much faster, much better, but then there are type 2 hypervisors are also available. I've given some examples, what type of bare metals are available and what type of hosted are available. But again, this is not a comprehensive list. You can literally search for type 1 hypervisor or type 2 hypervisor. You'll know more. Now, getting back to, this was the operating system. I'm going fast on this, and because I don't want to spend too much time on just hypervisors or the history of all this. Why did people decide to go to containers then, if they were able to segregate or utilize the hardware better with the help of multiple VMs on the same hardware? Why did they decide to go to containers? They, in 2013, a company named Docker, right, they came up with an idea to put every process that runs inside Linux operating system, inside a basically container. In the physical world, if you see a container, it has kind of 4 sides. It's kind of a box, right? Whatever you put inside the container, it stays inside that container, right? For example, your shoebox, right? You close the shoebox. If there is a pair of shoes, it stays inside the shoes. You have a shoebox. Similar story here in containers too. What benefit we are getting by doing this, right? We are removing this layer of VMs and replacing it with containers. But what is the benefit? Inside VM, you need to run full operating system. Because you are running full operating system, you need to patch it, you need to manage it, maintain it, update it. There are vulnerabilities. Your attack surface is too wide on a VM, versus inside container, you are running one process only. And everything that process needs to run successfully is already packaged inside the container. We'll look into it. I'll show you a live good example so that you can understand better, right? But how does it look like? You see the VMs are gone and we see Docker, 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 right? See this, these things, these containers, nothing special about them. There are, underlying Linux operating system features that make it possible. Uh, Now, what those features are, there are some commands. For example, there is a command called unshare, right? If you have time, type on a Linux box, say man unshare, you'll see. It explains you really well with the details of what are the namespaces, how things get segregated. You can kind of get into the weeds of it. But anyways, coming back to the containers, right? Containers are much more faster too, as compared to VMs. Why they are fast? Again, going back to the same story, no operating system, right? You are not running a huge operating system that need to be installed, configured, and finally you run one process on top of it. Versus container, you are just running a command and you have your container readily available within seconds, right? Okay, we will run few commands and see it. Now, till the time it was containers, it was well and good, but problem comes when you have too many containers and too many hypervisors or too many physical machines running hypervisors, and there are containers. Once you have these in thousands, how do you make them act as one cohesive unit, right? If you want to, for example, you want to run web server and you want to run 20 copies of that web server, right? If let's assume if we are still in maybe 90s or 1990, 95, maybe 1996, around those times, right? If you are in that time, you are trying to run a web server, you will install operating system on a physical system, and on top of that you run the your web server. You need to run 10, you need to have physical 10 machines to run it, right? You would do it that way. But then VMs came, maybe on two machines you ran 10 VMs, and that's how you did it. But with containers, you are doing the same thing maybe on very less, because now you don't need to kind of bear the burden of the operating system also, right? So if you need to run 10 web servers, those 10 web servers might be running on three different servers, right? How do you connect them? How do you ensure they are always staying in sync? How do you route traffic to them? All that required some sort of management, right? With that, Kubernetes enter into the picture, right? Kubernetes, basically this sign, it is called Helm, and Helm. If you recall these images, a Docker sign is the whale carrying those containers. You must have seen a ship full of containers, right? So whale is carrying a bunch of containers. That is Docker, right? Now, what we are trying to achieve with the Kubernetes is trying to manage thousands of such whales with so many containers. So you need somebody who can drive the ship, or you can who can run the ship. That's why this kind of makes more sense. In older times, ships used to have this wheel which you turn to kind of navigate your ship. But anyways, that's a different history for another day. With Kubernetes, you are able to control all these containers across thousands of physical servers, thousands of machines. You can define where should a particular traffic be sent. You can segregate who can run what traffic should be going where. So that is where Kubernetes enter into picture. I'm going a little faster because I know this topic or this episode is for experienced users, but still trying to cover as much as I can in terms of history. Anyways, okay, so what does Kubernetes looks like? How in if you want to see it live, in physical world, how does it look like? So it is made out of two major components. One is control plane, another is worker node. These worker nodes used to be called minions in old times, and this was kind of master controlling those minions. But anyways, uh, control plane has certain set of components that do different kind of activities. When a user makes a request to Kubernetes, whenever you need to, let's say, run a service on Kubernetes, you always interact with this central thing called Kube API server. This is the kind of brain of it, which kind of handles most of the communication. You'll see these arrows telling you from where communication is coming and where it is going. But your Kube API server is the heart of it. It keeps track of things, where a container is running, where it should be scheduled. It when it need to schedule, it goes and tells scheduler, hey scheduler, can you go figure out where should I schedule, right? So scheduler is that part. Controller manager, you also need a way to kind of continuously monitor, right, whether your containers are running fine or not. What if one process died? It is very common in Linux, right? You might have out of memory killer coming and killing a process. How would Kubernetes know? This controller manager is running control loops and trying to kind of keep an eye on everything, right? If something dies, it talks to Kubernetes API discuss with the scheduler, and they go and schedule it on another node. etc is the heart of it. Basically, it is key value store. All your configuration is stored in etcd. Okay, so we'll see maybe in one episode talk more about etcd. Then this cloud controller manager is something, it's a component which earlier used to be part of, I think, controller manager. It was segregated because Kubernetes or CNCF wanted to have uh, cloud vendors to kind of their own control on APIs or the way they want to implement services for their particular cloud. So this controller manager talks to cloud service provider, for example, AWS, Azure, or Oracle, right? Then on node, there are three main components that run on every node. One is kubelet. Kubelet is responsible for scheduling the pods, running them, starting, stopping them, right? When I said three, let's understand function of each, right? Kubelet responsible for pods, starting them, stopping them, killing them, whatever. Kubeproxy is responsible for, as name suggests, proxy for traffic, for communication between pod to pod, node to node, node to API. All that is magic is done by kubeproxy. It uses behind the scenes, it is using IP tables, but things are moving fast on Linux world. It is now, there are many tools available. For example, eBPF is another one, extended Barclay packet filter. Basically, it's a kind of VM running inside your container, much more faster than IP table. uh, you could replace IP tables with that too, but we'll talk about that when we go there. But anyways, so kubelet, it handles running the pods, stopping, starting the pods. Excuse me. Kubeproxy responsible for communication. You see something called CRI. CRI is container runtime interface. Kubelet is always talking to CRI, and CRI is what actually spinning up your containers. Now, it doesn't end here. There are a few hidden components that we have not shown here. One is, CNI. CNI is container network interface. CNI helps to connect these parts with the help of kubeproxy and everything to the outside world, or connect to each other, right? So that is function of CNI. There is another called CSI container storage interface. So with that, what you get is ability to use storage with your parts. When you are running a process, you want to have some file system. You want to save the logs. Maybe you want to have, file system mounted configuration file available within the pod. So CSI comes into picture too. There are other controllers too that come into picture, but basic to run your Kubernetes, you have control plane, you have nodes. On control plane, these four components, or five if you include the controller manager too. On nodes, you have these two main components, kubelet and kubeproxy. People don't really talk about CRI, CNI, or CSI, but those components are also needed. And with that, I have added some kind of references and details too. Okay, enough theory. We have talked a lot about it. Let me go back to the kind of top level directory, which says Kubernetes, and it takes us to this readme.md. And here is kind of something hands-on that we can do. It's a build a container to run a web server, right? So I I have provided the kind of full repository. If you go in project, inside that you'll find all the files that you need. What this container does, before I kind of start running commands, what it does, there are prerequisites. Definitely you need some of the tools that you would use to run this. Inside this directory, you have app.py. This is a application, Python based application. Doesn't do anything special. It serves /index.html page, which is lying inside that directory. It also serves a page /hostname. /hostname is nothing. So you see this index.html. I can show you here. Then app.py, you have access to the code. You can see what it does. Nothing special. /hostname is kind of serving the host name of the container. That's the idea, right? So let's get back to where we were. It listens on port 8080. There is a Docker file provided. We'll talk about that too. Then index.html, it displays the name. It says hello, requirements.txt. I'm using this when I'm putting the file inside the container. How do we build it? How do we run it? How do we test it and all that, right? I have given a lot of more suggestions that we can use to optimize this file. And with that, let's look at the Docker file first. When we say Docker file, what does it mean? What does a Docker file kind of contain, right? Docker file is, as you can see, set of commands or instructions that you pass to Docker daemon, and Docker daemon translate these and create something called an image, right? So that image, the image you create, is generally stored first locally. Later you push that image to a centralized repository. There are, Google has it, Amazon has public repository. Similarly, Docker has their own repositories. You push it to centralized repository. Why you need to push, or should you push, right? If it is, now first why you need to push, then we'll say should, then we'll talk about should we push. Why you need to push is, if you are writing a container or a Docker file and you are creating an image, you want to run that image on some servers, right? You don't want to copy that image with the SCP or other tools to all your servers, then run container from it. What you want is packaged kind of image in a central location. When you need to run your container, you just go and run a command, say docker run, and give the name of the image, and it downloads from there and runs it for you, right? So that's the idea. This also tells you another thing where you can see here requirements.txt. There are some commands I'm doing it here, but it is basically packaging everything that my app.py needs. Whatever packages Python needs to run this successfully are also included. So you'll see instead of running full-fledged operating system, we are running a very kind of a slimmed down version of that operating system. I have given some links where you can read more about it, but just very quickly, we are saying from where it should start building the image. This is we call base image. It is picking up Python, and this is the tag for that 3.9 hyphen slim is tag. So I'm saying when you start building this image, download Python and this specific version of 3.9-slim. Download that and then get into this directory inside the container and then copy content from this dot means my current working directory from to inside docker/app. Then a run basically is telling the container to go inside and run commands. We are basically running pip install command. And then finally, we are saying what port this container should expose. When I say expose, it means by default, or when we run docker run, we can say hyphen capital P, and it'll automatically make that port available to outside of that machine wherever you are running this container. Finally, cmd and some arguments. We are defining what should our container run. When we run a container, it need to have something which kind of continues to run in the background. If you, let's say you say instead of Python and all that, you say, for example, you replace all this and say date, your container will start, it'll print date and it'll exit. Date is not a command that will stay forever, in the background or in foreground. You need something that can hold it together, that can keep running, right? That is why you need to define it in a way, or you need to write your software in a way, or your application in a way that it doesn't disappear. So you'll find many Docker images where people are using sleep. They are running some infinite loops. People are using busybox images, and then they are saying don't exit basically, right? That's the idea. You don't want this command to finish and exit out, because if it happens, it'll happen so quickly that you won't even see your container run. Anyways, now let's see where we are and what we are doing, right? So it says docker build, you run this command, right? But if I'm at my laptop, I have docker. If I say docker ps, because I don't have docker installed on my laptop, you'll see this, it is not running. So what do I do? One way is I can download Docker Desktop, run that Docker Desktop on the side, and using that Docker Desktop, I'll have this Docker daemon running and I'll be able to run these commands, right? What other options are there for Mac OS at least, right? I am using something called Colima. So Colima start, if I say this, Colima start, what it is doing is it's gonna create a Kubernetes cluster on my laptop within seconds, right? You see we ran at 5:22:24 p.m. Right now it is downloading some images. You can see it created 100 GB disk or virtual disk, creating some serial console and all. Basically it is starting a Linux virtual machine on my laptop. This laptop is running Mac OS. That's why I need to use Colima. You don't need to do this, but this is one way of running Kubernetes on your local laptop. you want a quick and easy way of running a Kubernetes cluster, you can do this too. Colima start Kubernetes hyphen network address. Basically, it is creating a Kubernetes cluster on your laptop and it is making it available on your network too, or it is exposing the Kubernetes environment that it has created on your local private network, and it should be done within few seconds. So this is one of the way of doing it, and there are a few others that I have mentioned. So if you go on this multipass uh, install K8S, down below you will see some references. Here are some references, other tools that you can use. One is Minikube, Kind, K3S. Everything has its pros and cons. Again, it is not a comprehensive list. It is not everything that is out there. You can use anything out of these. Idea is to have some environment very quickly available for you to start playing with it. Again, I'm not going to use Colima for everything. I just wanted to have Docker. I didn't want to install Docker Desktop. I thought of showing you how does it look like if you run a tool to run container on your laptop, you, and you want to have your maybe Kubernetes clusters too. So you can see it is updating my kube config, switching the context and everything, it is done, right? So if you recall, I ran this command docker ps and it said there is nothing running, right? So 5:22:24, 5:25:31, within about 3 minutes I have a Kubernetes cluster. But anyways, let's run docker ps. You can see we are running few things, and those few things are you can see there is metric server running, core DNS running. There are few things that it installed on my system. But anyways, this is not what I wanted to show you. And what I want to show you is getting started with Docker, and let's see, Docker project. We want to make an image from that file, Docker file that we have, right? So let's see, what do we have? Getting started, no, Kubernetes, and inside that I had projects and Docker, right? So if I say lsl, you can see I have a Docker file. I have app.py, index.html, and requirements. So I can do Docker images. So you can see it shows some of the images that it downloaded, and they're different sizes. That's why it was so quick. But anyways, what I'm trying to build right now is you don't see anything that says my app v1. My app is the name that I want to give, and v1 is the tag that I want to assign. Basically, -t my app v1. That's what I want to build. What it is doing right now, it is, see, in the Docker file, if we look here, now let's try to compare from Python 3.9 Slim. You can see what it says, right? Sending this to Docker daemon, then it says pulling something from 3.9. It is pulling that Slim image, right? And then it is pulling some layers of it. Finally, it said, okay, I have downloaded that image. Once the image is downloaded, there is first layer of file system created within that image. So all the commands, anything that is not commented in this Docker file, is a layer in your image file. It is, your image file is nothing. It is a bunch of layers compressed together. It's a kind of tar file. But anyways, we'll see into that too. So first layer created, you can see it says step 2. Step 2 is work.dir. It went to that directory, and it removed the intermediate container, and now it has two layers. It went to third layer, copying the content. Now it is running another command to put everything inside the container, basically requirement.txt. Anything that I have written inside requirements.txt, it is installing that. You can see it is running commands. Those commands are running inside containers. It is showing some kind of warnings because I didn't say apt update and all that. So it's all right. We can ignore these. Finally, you can see next command was expose, and here also it is a layer getting created. Finally, it is creating this image where, sixth command. So if we count from here, that is one line, this is second line work dir, third line is copy, fourth line is run, fifth and sixth is cmd. And that's why you see stage 6 of 6, and successfully created the image. It created this image and then it tagged also. You can see it's a successfully tagged. So if I do docker images and let's grep for it, grep this guy, copy paste, you can see it shows my app v1 and this is the image. But anyways, let's see docker images. You can see created my app v1. It was created about a minute ago and 216 MB size. We can reduce it. We can reduce the size to a much smaller one. I have left that portion out, but I have very clearly kind of highlighted what other things we can do to kind of optimize this container. I won't say this is the kind of most efficient container available out there, but it serves the purpose. Anyways, next is running the container. I'm not going to click enter. I want to show you what happens if we do 127.0. So what I'm trying to do is go to 127.001/80. You see it is doing, I don't know why it added http:// and you can see here Safari could not open this page. Right? Okay. All right, you can see it is not able to open the page, but let's see. Let's run this command. What it is doing, this was a image only. Now we are running copy of that image on my laptop and it has created a container. So how do I even see it? What does it mean when I say container created, right? So docker ps, if I do docker ps, you'll see 21 seconds ago, this my app v1 was started, right? What else we can do? Docker, instead of ps, let's see, docker ports, right? Docker port my app, because that's what I named it while kind of starting it. You can see name, right? It says my app. And now it tells you on your laptop 8080 port is being forwarded inside container to port 8080, right? This command, when I ran, I said, what is the local port, where should it go? You can do docker run help and understand it. So the output that it shows http 00/8080, it means it is listening on all interfaces. But please understand, it is not listening on your laptop. It is listening within the container. That means if you don't expose it, or when you are running this command with the -p, if you don't specify this, you'll not be able to access it because it is inside its own environment, own little environment. But anyways, let's see now. Let's try refreshing. Ooh, we have a container, right? So let's see. welcome name, right? So what it does, it says welcome to container this welcome name. So basically it's just nothing, it is just echoing out what you are writing there. If I write my name and say submit, it says welcome to container this and Hardeep, right? So from where this thing is coming, 2856, you see container ID here, 2856. Python script is pulling with the help of that slash host, which I was showing you earlier, right? That's about it. So congratulations, you have a container running, and I have not installed Python on my laptop. That Python was installed inside container. I have not messed up things on my laptop. I can literally go inside that container, delete things. Nothing will be messed up on my laptop, right? Everything is happening inside container. But be very careful. There are ways where you can mount your underlying operating system's file system inside container. You can do things, for example, very advanced things, for example, chroot. You can kind of take over the host as well if somebody has not kind of controlled it. This Docker container is running as root right now. It's a privileged container. There are many things that we could do. For example, we can define a specific version of the image. We can reduce the image size. We can build multi-stage images, remove root user, run it as normal user. Again, going back to the multi-stage build, we can use this to reduce the size drastically, copy only what is needed. We don't need everything. Optimizing the layer caching, pin dependency versions, health checks, all those details I have mentioned here. I have provided all the references that you can use with it. So if you like to kind of learn more about any one item of these, I would say please go and follow these links. Let's go back to our multipass install K8S script as well, and let's review what all it provides. Why do I need to create it? What multipass is? Multipass is a Ubuntu software. Basically, you can run a single command to create VMs on your laptops. It is to create a basically learning environment without any dependency on clouds. Uh, it has features like cloud in it, similar to what your cloud service providers has. Um you can create disposable kind of clusters to do hands-on learning. Uh, you can use it for exams, for example, for CNCF exams, CKA, CKAD, CKS. For all that, you can use this multipass. And what are features does it have? Before I go, I wanted to kind of touch base again on why was it created. Dependencies, no dependency on cloud. That is, I think, main thing that I had in my mind. Disposable infrastructure creation, that was another. Okay, before I go ahead, I think I'll start the installation so that our installation completes by the time we are done reading through it. Okay, if you run help, you can see some options that are available with the script. You can do pre-install. It does few things before it installs. Install, post install, set context, status is the cluster node status. K8S status is for your cluster components, for example, Cilium connectivity. You can run start, you can run stop. You have uninstall, be a bit careful with that. It'll basically go and delete your VMs. Snapshot all is another ability where I was talking about disposable infrastructure. You can take snapshot of all your VMs, go modify it. That way you don't need to worry about you have made changes. Let's run start. Oh, I should not be running start. I think I should be running install. All right, let's go. Let's get started. All right, you can see it is already building the VMs. Let's get back to our README. It's creating one master and two worker nodes. It'll assign the private IP address, configure the SSH cloud init, automated installation of containers, container D, run C. I'm doing all these, kind of trying to be on the edge. All right, let me stop that VM which I started with Colima. This laptop has enough resources, but still, I don't want to constrain my resources while I'm trying to build three another kind of heavy VMs. Each VM is 10 GB storage, about two CPUs, I think 3 GB RAM or so. This is kind of beefy laptop. It has 64 GB RAM, iCore 9 processor, but still. Let's take a look how it is going. Okay, it is initializing. It is installing. Okay, coming back, it installs container D, run C, CNI, kubeadium, kubelet, kubectl. I'm installing Cilium using Helm because I want to do my exam on Cilium. Wanted to do a playground where I could go and run commands. And we are also, with the help of this, uh, yeah, see, referring back to that, I need to do some exams for CNCFs. You can use this environment for CKA, CKAD. Cilium CNI is one of the exam for uh, and next, I have features for easy rollback, which I talked earlier about. And given some commands, it tells you, I'm doing, you can run it on Linux, Mac OS, you can run it on Windows too. Multi-sh multipass, sorry, multipass is available for Windows too. There are other tools like kubectl I installed locally, but it is not needed to be local. I could have done it within the container itself, but anyways, I installed it because I wanted to have a way to access it. uh, you need to have tools like curl, sh keygen, bash, basically all the tools that you need to run a few tests and commands on your machine. Again, you need to have some beefy machine to run three VMs. What this script does, how do you run it? You run the script, it gives you help, and you can say script and help to see what all options are available. This v33 is nothing but it is 1.33, that's Kubernetes version. I named it as 33 only. It looks for multipass. Basically, before script runs, it does all these checks, sh keys generation, cloud init. Cloud init, it is creating VM user, it is setting up a passwordless sh and sudo. Then three VMs which I talked about, one master, two workers. It is assigning private IP address, 10 GB disk, 3 GB RAM, two CPUs each. And we are also using netplan to configure static IP address. All the links are provided down below. Then we are also installing some components. Before we do installation, we are updating etc host file. All this is done by script, and in host file we are making those entries. We are updating some kernel parameters, then installing container D, run C, CNI, kubeadium, kubectl. I wanted to kind of be on kind of cutting edge. I'm doing it manually, it's not needed, but still I'm doing it anyways. I wanted to kind of have a ability and make my hands dirty. CRI CTL, I installed it because CKA CKD exams, they use CRI CTL, and it will be a good tool to use and get some hands-on experience, because it is kind of being used in current exams too. And next we are doing cluster initialization. We are doing master node with kubeadium. We are running kubeadium in it. Oh, that's a mistake, looks like I need to fix it. That's planner. Setting up a kubeconfig, Cilium CLI, I'm doing it by Helm. And CLI, okay, the CLI, CNI is container network interface, command line interface CLI. Okay, worker nodes, we are automatically generating a script to join the cluster, running the script, transferring kubectl, and finally at the end we are running some verification commands. We are running kubectl get nodes. Again, you could go modify, you could play with it. It is mostly to do stuff. You can modify the script if you like. Let me Okay, let's continue. I mentioned you could modify the resources. We looked at 10 GB disk, 3 GB RAM, and two CPUs. All that could be modified in the script if you don't have enough resources. We are setting static IPs with netplan YAML file. We are defining different Kubernetes component versions, and I have provided links for almost all the things that I have used in the script. I provided references. You can look into Cilium, CloudInit, and all. Again, this is something we saw earlier. All the tools that are available that you could use. People play with Minikube mostly, but I wanted to have a way kind of to play with my system and then finally K3S is interesting. It started with the K8S. K8S is between K and S, there are 8 characters. That's why they call it K8S Kubernetes. And K3S project was focused on reducing the time to half. So they slashed 8 in half, and that's what makes it K3S. Now, that's a interesting bit of history. Idea was to kind of slash the time or resources needed to run Kubernetes to half, and that is how there is no acronym or something for it. It is just cutting that K8 into half and making it K3S. I micro K8S. This is another distribution. You could run it on your laptop, and yeah, I've given some pros and cons for every one of these. Let's take a look at the script now, and looks like our installation is going well. All right, I have provided details about disk memory requirements and all in the comments too. Then we are setting some colors to ensure you could kind of see it better when you run the command. If there is error, you could see it kind of in different color. And with the pre-install, you can see we are checking if there is multi pass installed. We are running sh keygen to generate the sh key that we will be using with the VM user. And this VM user we are going to use to SSH into the nodes. We are defining 2048, the size of it. But anyways, let's keep on going. Cloud in it, we are defining sudo here. You can see the username and sudo access given all no password. We don't want it to prompt for password. And then finally using this private key, and we are using public key for this, and it get added into authorized keys. Again, I have provided links to the documentation. Go check it out. And then we are installing our master. You can see disk, memory, and CPU are defined here. You want to go modify. Cloud init is here, and netplan, which is helping us to kind of define IPs, static IPs. This is the command we are kind of configuring netplan, and finally kind of running those commands. Netplan apply. Scrolling down, going to cube worker, similar story here. 2 CPUs, 3 GB and 10 GB disk, 3 GB memory, 10 GB disk. Again, running cloud in it, and defining the MAC address and all. Right, so it again goes sets up our sudo ssh, all that. And here is the net plan for this node. It has a different IP address. We are defining a static IP here too. Right, so now let's keep going. We are looking at worker node 2. All right, and we have 2 CPUs, 3 GB memory. Okay, let me close it. Okay, and we have 2 CPU, 3 GB memory, network configuration, then cloud in it, and finally defining an IP to it as well. And in installation, I'm calling almost all the functions that I created. And during configuration, I am kind of going over per node and installing things. Remember, I mentioned etc hosts. I'm making those entries, then adding modules. For example, net filter module, overlay module, that kernel loads, and we use it later. And we are defining sysctl parameters that are used by kubeproxy. Um, Something important, yeah, some net filter. We are doing some bridging, and then finally we are bleeding edge version that I talked about. We are installing that, then CNI plugins. uh, okay, so we are installing some CNIs too. If you see, I'm kind of fetching them from GitHub and installing them. Again, don't do it in production. This is playground only. I'm doing it, then installing all the required packages, setting up the aliases so that I can use K instead of full kubectl. And finally, we are kind of defining our CRI-CTL config. Uh, and here you can see we are initializing our cluster with the kubeadm init and defining the CIDR, API server IP, and all. Right. Once this finishes, create home directory and copy the kube admin.conf to kubeconf. And yeah, here we are installing Cilium with the help of Helm, and I'm configuring few things. I'm installing the Cilium CLI inside the VM as well. Master node I do have on my laptop, but I wanted it there too. And then we are getting the join token, creating a join command. That command gets transferred, and finally we log into each worker and execute that join command. You can see how here is where I'm running that command to create join worker, and this is where I'm copying the kube config, and that copy gets transferred to worker nodes. I don't recommend doing it, but anyways, it is my test environment. I'm doing it. You don't need the kube config on workers. It's not recommended. I did mention right above the selection. But anyways, moving on, then we are kind of finally printing get nodes just as a end of it to see the status. After post install, this is all kind of pending to dos. You can add, I was experimenting with some changes on SSH, but you can add things, remove things as you please in the post install section. That's for future only. Okay, generate context. This is what we are using. I didn't want to use admin user, so I want to kind of do some hands-on too, where we are adding a user to our Kubernetes cluster, and then using that we are finally creating a context, adding it into our kube config. So you can see I'm creating a key for that user, then creating a certificate signing request. The signing request gets copied over to our kube master, and you can see I'm doing kubectl apply, and then approving the certificate, getting the CSR, and getting out only certificate from that output of kubectl, and it gets decoded, stored in bmuser.csr. I'm kind of transferring it back from that master to local, and then finally I'm setting my kubectl config, creating context, adding credential, and finally setting it to use context of VM user Kubernetes local. Right, so commands are given for almost everything. You can see I'm using VM user. I'm specifying the certificate that I copied over from there. And finally, look at after all this is done, we are looking at namespaces and just looking at pods, if there are any pods created or what namespaces are created. Uh, with status all, okay, let's see how it is doing. Okay, it's going well. It is still progressing. Now with status all, we are having three nodes. We are just checking the status of those nodes only. We are just running a loop. I didn't need to do this. I could have done a for loop, but anyways, multipass list. We are checking the status, and it just prints the status. It also gives you set of commands that you can run later, right? You can see it is, I'm going over the array to kind of print the status, nothing fancy there. You can see in the end it is kind of using those environment variables to print things, but these are commands that I'm highlighting. These commands you can use to get inside your VMs if you like to. Again, this is just provided as help. If you want to see what your VMs are doing, how they are doing, you want to get inside, you can run status, right? Script and status. Now let's look at status all. This K8S status all is to basically check how are cluster components inside the cluster doing. Mostly I wanted to see how Cilium is doing. Again, we are checking if our cluster is running. If cluster is not running, it exits out. It again checks if it is started or not running, and then we are kind of running commands inside the cluster. We are creating a namespace. Inside that namespace, we are running some connectivity checks, and yeah, we are waiting for pods to get ready. We are doing cleanup, deleting them. Finally, we ask a question to the user: do you want to run a longer test? Right? If somebody says yes, it'll run the Cilium connectivity test. It'll take about 15 minutes to complete, but that's about it. That's what it does. All right, looks like our installation has finished. Yes. All right, this is what I was talking about, setting context and switching the context to use with that user. Our namespaces are ready. Let's see if how our nodes are doing. kubectl get nodes. All right, good. We have our nodes available. They show not ready, but let's see. All right, kubectl get pods a. Looks like our pods are still getting started. Nodes are not ready yet. Let's give it a few minutes before we can say our cluster is 100% ready. And with that, yeah, let's take a look at our script. Where do we stand? Okay, it just, printing. If you say no, it'll show you that I'm not going forward. Let's see. Start all is, if you stop your nodes, it just does, start multi pass start, and each host at a time. Similarly, we have other functions available like start. We have a stop function that stops all the VMs. Snapshot all, this is what I was talking about. You can take snapshot and then restore. Uninstall all, it is a bit dangerous. Be careful, it's going to go and delete all your nodes. So yeah, here, finally I'm using case to kind of print everything and call different functions. Let's close this and let's check the status again, how it is doing. Looks like it is still creating containers, so almost there. I will give it a few minutes before we kind of wrap it up. All right. All right, adding a section to the video, I just wanted to show you, uh, before I closed my video, I had some of the containers related to Cilium were still starting up at 520, 557, 559, didn't do much, didn't make any changes. I had my containers running. You can see everything is up and running, and I have installed Cilium on my laptop. So if I do Cilium status, it should show everything up and running and okay. All right, with that, we are done. Thank you everyone for your time. We'll meet next week. Thank you.